Okay, hello everyone. We're still short quite a few people who had registered, but I think I'll just get started with the presentation and they can join in whenever they're able. So yeah, good afternoon everyone, and thank you for joining us today on our first foray into producing webinars. My name is Brett Campbell, and I am the Stakeholder Engagement Coordinator at the Alberta Biodiversity Monitoring Institute, which I'll just shorten to ABMI from here on in. And I'm joined here today by Branko Hricko. Say hello, Branko.
Hey.
So yeah, I'll just jump in here. Last year, we completed a 10-year review of our operations. And some of the feedback we received was that our stakeholders were interested in the ABMI delivering webinars about its tools and products. So that's what brings us here today. We are starting our webinar series with an introduction to the human footprint monitoring activities of the ABMI. I'd just like to say now that if you have a lot of experience working with these products, this might not be the webinar for you, just because we're going to be providing a fairly high-level overview. So some of the objectives that we set for today's webinar are to, first and foremost, increase awareness and understanding of the human footprint inventory. So we'll provide a bit of an introduction, some methods we use to create it, and some of the results and applications. Secondly, I'd like to introduce you to our new online reporting format. In the past, ABMI has produced print reports, but we are now moving away from this into the realm of online reporting. So online reporting allows us to have more flexibility with the reports. They're basically living documents that we can update over time. We're also designing them to be interactive and easy to navigate, so you can more easily find the information that you're most interested in. Our first entirely online report is the Status of Human Footprint report, which we developed earlier this year, and I'll walk you through that quickly in a bit. And finally, we recognize that you probably have some questions about the human footprint inventory and monitoring activities of the ABMI. So for that reason, as I mentioned, our GIS coordinator and human footprint monitoring expert, Branko, is present, and we'll be able to answer some questions at the end of the presentations. So with that, I'm going to jump in. I don't see anyone telling me that they can't hear me or anything like that, so I'll just jump into the rest of the presentation. If you have any questions as I go through the webinar, please just write them down, and I think we'll have about 30 minutes for questions at the end. So before I get right into the human footprint content, I thought it might be important to provide a quick overview of some of the work that ABMI does for those of you who aren't very familiar with our organization. So we are an arm's length, not-for-profit, with a mission to track changes in Alberta's wildlife and their habitats from border to border, and to provide ongoing, relevant, and scientifically credible information on Alberta's living resources for Alberta's land use decision makers and also for Albertans. We operate under principles of independence, scientific credibility, transparency, and of being relevant and accessible. You would probably know us best for our species and land surface monitoring activities, but in addition, we are involved in the realm of citizen science with our new app called NatureLinks and an upcoming environmental sensor network platform, WildTracks. We also perform numerous knowledge translation and reporting functions, including the one I'm introducing you to today, and plenty of practical applications of the data we collect, including ecosystem services assessment and climate change adaptation applications. To complete this work, staff from our 6 centers do everything from the fieldwork and data collection to processing, analysis, and application. We have about 70 full-time staff and associates year-round, and then also recruit 50 to 70 seasonal staff to support field data collection. So some of you may be familiar with this already, but this is a map of the grid of sites we have across the province for status and trend monitoring of species and habitats. Sites are spaced out at points every 20 kilometers across the province, and at each site we visit both a terrestrial and aquatic site, and we collect information on 7 different taxonomic groups, including moss, lichens, mites, vascular plants, mammals, birds, and aquatic invertebrates. We revisit these sites approximately every 7 years to gather information that can be used for trend monitoring of species, habitats, and land surface. But what we are here today to talk about is part of ABMI's land surface monitoring activities, human footprint. ABMI officially defines human footprint as the visible alteration or conversion of native ecosystems to support temporary or permanent human land uses. This definition includes all areas under human use that have lost their native cover for extended periods of time, such as cities, roads, agricultural fields, and surface mines. It also includes land that is periodically reset to earlier successional conditions by industrial activities, such as forestry harvest areas and seismic lines. Some uses, such as grazing, hunting, and trapping, are not yet accounted for in our human footprint analyses. And at present, the measure of human footprint does not account for successional recovery following temporary disturbances such as logging. So, for example, a regenerating harvest area is treated the same as a more recent disturbance of the same type. ABMI reports on 6 categories of human footprint. So agriculture, which includes annual and perennial cultivation. So that means crops and tame pasture. In addition to confined feeding operations and other high density livestock areas. This also includes forestry footprint, including clear-cut and partial cut logging methods. Energy features such as mines and wells. Transportation features such as railways, roadways, and trails with hard surfaces. Urban and residential features, including buildings and disturbed vegetation and substrate associated with urban and rural settlements. So homes, malls, golf courses, and recreation areas. And human-created water bodies, such as canals, reservoirs, or municipal sewage facilities. The ABMI monitors the status of human footprint using satellite imagery at 2 spatial scales. The first I'll discuss with you is our 3x7 sample-based human footprint data. ABMI uses human footprint data measured annually at a 1 to 5,000 scale to track changes in human footprint over time. Detailed annual samples of human footprint are measured in a 3 by 7 kilometer rectangular area centered near each of ABMI's 1,656 monitoring sites, which when summed across all sites amounts to approximately 5% of the province's land surface. ABMI human footprint trend data are available from 1999 to 2016, with the exception of 2000 to 2003. This is a very cool video created in-house to provide a clear picture of what exactly the 3x7 sample-based data is. We always joke that it should be set to the Game of Thrones theme song. As you can see, it's a 3 by 7 kilometer rectangle at each of the 1,656 monitoring sites. We also visit to collect species and habitat information. Each one of these rectangles is manually digitized by one of 6 full-time year-round staff we have here working solely on heads-up digitizing for human footprint products. Creating and maintaining these products is definitely a Herculean effort. The second product I'll speak about is the human footprint inventory. To measure human footprint at the provincial scale, ABMI merges 20 human footprint sublayers based on 115 feature types into a single integrated layer by applying a specific order of precedence to create the ABMI human footprint inventory. The 3 by 7 kilometer trend data estimates I mentioned in the previous slide are standardized using the human footprint inventory. Some of the sublayers used in the human footprint inventory are created as part of the Alberta Human Footprint Monitoring Program. So that's a collaboration between ABMI and the government of Alberta that's been happening since about 2014. And it has an objective to increase the accuracy of human footprint data. This product is updated annually most recently for 2016, and we're already working on the next product for release. So this is a visualization of how some of the 115 feature types or types of human footprint are digitized and how they're merged into the 20 different sublayers. So where the colors are showing up is where we've mapped and coded different types of human footprint. You can see in this illustration that there are several types of seismic features mapped, for example. These different seismic features are merged into one more general sublayer that's categorized as seismic for the inventory. Here you can see the footprint of each of the 20 different sublayers individually, presented in their order of precedence in order to create the one integrated layer. The table on the left also shows who the contributing partners to each sublayer are. These sublayers are also available individually on our website for those who are interested in just the individual sublayers on their own. So that's all of them together there. This slide provides a bit of a snapshot into the integration process and in order of precedence for the 20 different sublayers and the 2016 version of the human footprint inventory. So anytime a new feature is added on top of another, the footprint underneath is cut away so that we're not left with stacked human footprint in an area. So this slide might have a bit too much detail for some folks, but there were some who mentioned in the pre-webinar questions that they were curious to hear a bit more about the accuracy of the human footprint data. So the simple answer is that the accuracy is completely dependent on the data source, so which we're presenting here on the table. So for example, you can see that the Alberta Vegetation Inventory, or ABI, is accurate to about 20 meters. The heads-up digitization of spot imagery is accurate between 10 to 20 meters. And the primary land and vegetation inventory, or PLVI, is accurate to about 5 meters. If this is something that you'd like to get into a bit more detail about, Brinko is here, so he could answer any questions at the end of the webinar. And I'll also have our contact information posted. So if you'd like to do a little follow-up after, that's definitely possible too. And as with any product, the human footprint inventory is not without its limitations. So a few include that, first of all, it is out of scope for ABMI to update low impact seismic lines annually, just because of their sheer density and the manpower that it would require to digitize them. Secondly, prior to 2014, there was no polylines dataset for those who require it to do analysis on linear features. It was created in 2014 as part of the Alberta Human Footprint Monitoring Partnership that we have with the Government of Alberta. Prior to that, linear features were digitized exclusively as polygons. And thirdly, we inherited data for the rural residential areas for the years between 2007 to 2012 and recognize that the data set is not reliably accurate. So there's some noise in that data set. And now I'm going to share a brief overview of some of the results of our human footprint inventory from the provincial perspective. So remember, these results can all be isolated and shared on smaller regional scales if desired, but for the sake of this webinar, I'm going to share them provincially using the most recent 2016 release of the human footprint inventory data. As of 2016, approximately 29% of Alberta had been converted for human land use. So this table shows how that 29% is divided among the 6 categories of human footprint that ABMI reports on. Agriculture, represented in yellow, has the largest share of human footprint in the province by a long shot, followed by forestry and energy sectors. The rest of the categories like transportation, urban, industrial, and human-created water bodies are at, around, or just slightly less than 1% of human footprint in the province. This map provides a visual representation of where these areas of human footprint occur by category using the corresponding color. And in this graph, we can see the province-wide change in human footprint over time. So over the past 17 years, there's been a province-wide increase in human footprint of approximately 4%. The most significant increase by category is the forestry footprint, which has increased by 2.26%. For contrast, the agriculture and energy footprints have increased by about 0.6% each. And here we're showing the absolute percentage of human footprint created in the province. The areas in dark red show high percentage of human footprint, whereas the lighter shades of yellow are showing smaller percentages. So now I'd like to just quickly point out that all the maps that I've shared here are also available on our online mapping portal, which you can access at abmi.ca/maps. And I'll also show you where they are on our online report. Just before I do that, I'd also like to point out to you that our data is made publicly available through our online data and analytics portal. Once you hit the data and analytics portal, you can navigate to the data download section, and here you'll find everything, all of the data that we have. So from land surface monitoring data, such as the human footprint inventory, and other data sets, including our species and habitat raw data and species level data sets. This is also where you can find the metadata for our different layers. Traditionally, we have produced print reports to share the results of our human footprint monitoring. So as I mentioned before, just this year, we've begun to move toward producing exclusively online reports. This is a look at the homepage for our Status of Human Footprint in Alberta online report, which uses the latest available 2016 data. We've moved to online reporting for several reasons, including because it provides us the ability to update the report on a regular basis. It also allows for quick navigation for users to information of interest, and because we can include links to other online data platforms directly within the report. So now I'll quickly scroll through the online report just so you become a bit more familiar with it, but I definitely encourage you to explore it in a bit more depth following the webinar. So here is that homepage for the Status of Human Footprint in Alberta online report. If you look along the top, you'll see a menu bar with some different options. If you click on background on the left, you come to all the information that I just provided you. So just a bit of introduction to what human footprint is, how we define it, the different categories, and how we measure it. So some of the methods. You can also look at some of the results of the human footprint inventory by different areas. So if you click on Alberta, again, this is the information that I just shared with you. So the human footprint inventory on the provincial scale. The data is presented in area, so kilometers squared, and area as a percentage in this table. You can also click to view it as a graph. This graph is interactive, so if you scroll over it, you can see the different percentages associated with each type of human footprint. You can also toggle through the maps. So this first map shows human footprint with all of the polygons outlined to make them more visible. The next map has them unoutlined, and the third map is a heat map. You can also see here that there's a link to the mapping portal that I just mentioned to you. So I'll just click on that quickly. So if you click on that, you land on our mapping portal, which is an interactive portal and that allows you to interact with all of ABMI's data that we have available. So you can select an area of interest or the different data sets that you'd like to look at. So we have the land surface data and also our species data and even some of our ecosystem services data there. So that's just a quick look. I definitely encourage you to explore that more because we have lots of information available on there. If I scroll down here, we also have the trend data available that I showed you earlier. And once again, this is interactive. So you can scroll over this graph to see different information and also view this table in either percent area or area in kilometers square. The other feature available is that along the menu here, you can isolate different human footprint categories of interest. So I'm just clicking along the different categories. This is forestry. Here's human created water bodies, transportation. So like I mentioned earlier, it's really interactive. If you're not interested in seeing human footprint on the provincial scale, but you'd like to get down into different regions, you can select by natural region. So I'll just click on parkland because I'm in Edmonton right now. And all that information is available just isolated to that region. So once again, human footprint type as area in kilometers square, percent. Click to view it as a graph, and you can scroll through the different maps and see trend. So we also have that available for land use planning regions and the oil sands regions. In the top right corner, there is a link to download the PDF version of the report. So if you prefer to have something that you can print and carry around with you, I'd encourage you to click there to download the PDF report. So that is just a quick introduction to the online report. I'll now move to discussing some of the applications for the human footprint data. So there are a number of ways human footprint data can be used to support land use planning and natural resource decision making. I'll now describe for you one application of human footprint data as an example, the effects of different sectors on species. This case study examines how different species respond differently to human footprint types. So for example, a species that prefers young forest for nesting and foraging may show a negative response to cultivation because of habitat loss, but a positive response to forestry because of the creation of suitable habitat in harvest areas. The total impact on a species is determined by, first, how strong the effect of the footprint is. Secondly, where the footprint occurs and whether it overlaps with preferred habitat of a species. And finally, the total area of footprint. So the total effect of human footprint on a species population is simply the total area of the footprint multiplied by its effect per unit area. So today I'll discuss specifically the example of different sector effects on the black-throated green warbler. These maps and analyses are created using not only our data, but data from Environment and Climate Change Canada, the Boreal Avian Modeling, or BAM project, and Dr. Aaron Bain. So the black-throated green warbler is a neotropical migrant that breeds in mature and old forests throughout the boreal and foothill natural regions of Alberta. This map shows detections of the black-throated green warbler at ABMI sites with larger red dots. The squiggly lines are breeding bird survey and BAM detections, and the small red dots depict sites where ABMI has visited and not had detections of this bird. So far, there have been 912 detections of the bird. Detections are combined with ABMI's land cover data, which is not pictured on the screen, to generate the following species habitat associations model. So this figure is a species habitat model. You can see there's relative abundance on the y-axis and vegetation and human footprint types on the x-axis. The bars with lines indicate 90% confidence intervals, and the dots show predicted species abundance in harvest areas of various ages within the different forest types. This species habitat model shows that the black-throated green warbler has, unsurprisingly, increasing abundance in old, deciduous, mixedwood, and upland spruce stands, and is basically absent from lowland forest, young stands, and human footprint, with the exception for regenerating harvest areas. So then we add human footprint information in a variety of ways to understand how human footprint is changing the relative abundance of these species. Sector effects include the unit effect on the y-axis, or average effect of the sector on a species per unit area, and the area of footprint on the x-axis. Height of the bar shows the effect of the sector per unit area. So, for example, how much 1 hectare of the human footprint type would increase or decrease the species compared to the natural vegetation that it replaces. Width of the bar shows the area of the human footprint type in the region. The area of each sector-specific rectangle, which is equal to the unit effect multiplied by the area footprint, is the total effect of the sector on the species' relative abundance in this region. This analysis was run for the foothills and boreal natural regions combined. In this region, you can see here that the forestry footprint has the strongest effect per unit area on this species. Overall, forestry is estimated to have reduced the regional population of this species by about 18%. The other footprint types have negative effects on the species as well, but their total impact is smaller just because they take up a smaller area. So we can also look within the actual areas of footprint to evaluate the different sectors' effects. On the left, we are evaluating within the same region, but only taking into account the areas already converted to human footprint. On the right is the effect of different sectors averaged across the region that I just showed you. So as you can see, this species does not do well in areas of human footprint, but when the results are averaged across an entire region, the impacts appear much less significant. So it's possible to run these analyses for hundreds of other species that ABMI collects data on. This is the example with the alder flycatcher, which, unlike the black-throated green warbler, has the highest abundances found in young upland forests regenerating after harvest. Also like the black-throated green warbler, forestry has the strongest per unit effect on the alder flycatcher out of all the sectors. But in this situation, the species experiences a 30% increase in predicted population abundance due to forestry activities. This is due to their affinity for young, regenerating, harvested areas. The other footprint types have minimal negative impact on the predicted population size of the alder flycatcher, but their impacts are smaller just because, again, their footprint covers a smaller area of the region. So the second application that I'll discuss is the prioritization of areas for restoration. In this case, as an application in caribou management strategies, research completed by our Caribou Monitoring Unit, or the CMU. Woodland caribou are declining across much of Western Canada, and there's an urgent need to understand how we can stop or even reverse these declines. The energy sector has been linked to their declines primarily because linear features from oil and gas are thought to increase their susceptibility to predation. Or specifically, linear features can increase wolf hunting efficiency or decrease spatial separation between caribou and their predators. The CMU works to understand why caribou are declining, what caribou management tools there are, and test these various recovery options. So habitat restoration, especially of legacy seismic lines and other non-permanent disturbances, is a huge focus of caribou management. But the question is, how do we effectively use limited resources to make the biggest impact on caribou populations? And can we keep in mind that the energy sector is continuing to be active on this landscape? So starting with a landscape that looks like this, with varying levels of disturbance in each township, how can we decide which to target? The CMU approached the question using bang for buck logic. So where can we get the most return on our investment? The first step is the bang, which tells us what we get out of restoration. So this slide kind of says it all. The two townships at the bottom look to be our best bet. But what is the cost of restoring all the seismic in each of these townships? In this case, the CMU used line density as an indicator of cost. More lines mean more money to restore. So we divide the bang by the buck, and those townships that get the most undisturbed habitats for the least amount of resources have the highest priority. But then we took into account where the energy sector was likely to go next by including the resource value of what was underground. So essentially, we adjusted the bang for buck by how much that township was worth in the future for development. It effectively lowers the priority of townships that are likely to be developed in the future. The end result is all the townships in each caribou range being prioritized from low to high priority. Once candidate townships are identified, more fine-scale decisions can start to be made. The tool is available within all of the COSIA area, spanning 5 caribou ranges, but it's also easily extended into other areas where the data exists. So most places in Alberta and BC. For the sake of time, I'm not going to go through any other applications, but if you're interested in seeing more, I'll encourage you to visit the publications section of our website to download that PDF report I had showed you earlier, which includes an application on identifying native habitat. This is the same report that's also available for download from the online report in that top right link that I had showed you. So that brings us to the end of our scheduled programming. We'd now like to open the floor to questions. I have our GIS coordinator, Branko, with me here, and he'll be able to answer any technical questions that you may have. And again, if you have any that you'd like to follow up with either of us following the webinar, this is our contact information, so feel free to contact us at any time. So let me just see if I can open the chat. So I don't see anyone having asked any questions yet. So I prepared a few questions just based on some of the feedback we got before the webinar. The first one had to do with what ABMI is doing to account for the recovery of harvest areas in the human footprint inventory. So I wonder if you could speak to that a bit, Branko.
But basically, the way how we approach it on human footprint inventory dataset, we stamp each polygon with year of origin for harvested area. And once you have that, then there are known models how you can calculate recovery rate based on how old the cut block or harvested area is and predicted land cover. So, but on human footprint inventory side, we just add that year value, and it's up to the user to use that year value for their analysis.
Okay, thank you for that. It looks like we have, oh, that's not a question. John. Okay, I have another question that someone had asked. Oh, Sean Francis had his hand up, hand raised. It's now down. Okay, I'm going to go to another one of our questions that I have prepared just based on some feedback. The next question was having to do with any improvements or changes that may have happened to the human footprint inventory in the grasslands region of Alberta. So I don't know if there's anything you can speak to that, Franco?
Yeah, sure. I mean, not specifically to the grassland region, but even for entire data set, we always look for improvements, generally speaking, in two areas: to increase thematic accuracy of the data set and to increase spatial accuracy of the data set. To do that on thematical side, we have increased number of feature types, so categories that we can interpret from imagery as a different types of human footprint. And on spatial accuracy, we are stepping back as much as possible from buffering method of creating polygons. So for each new polygon, instead of buffering technique, we use on-screen digitization. But also at this place, I would like to mention that has already been mentioned through your presentation, Brad, that we actively cooperate with Government of Alberta through Alberta Human Footprint Mapping Project, and that has been proven to be very beneficial to human footprint inventory, as people from Government of Alberta actively actually contributes to create some of the sub-layers, but also it allows us to have the pool of subject matter expert and basically people that really understand the field that we can tap into in case there are some there are some requests for any support. And also maybe I can mention that instead of a biannual frequency of updates, right now we have increased that frequency for annual update on provincial scale for entire human footprint inventory.
So Dan Wismer, I hope I said that right, has just actually on that note asked when the next release is.
Well, we are currently working on human footprint inventory for 2017, and it is expected to be released on March of next year.
Okay, great. So Sean Francis has asked, are you considering any automated approaches to digitizing human footprint?
Well, on our side, as I said, one of the automation is creating polygons from points or from lines, and we actually are doing that, let's say, for linear feature instead of, let's say, digitizing roads on both sides as a polygon. We start as a center line, but instead of using general buffering distance for entire province, we measure distances for each individual road from the center line to the verge or to the edge of the disturbance, and we use that specifically for that road to buffer. As for any other automated ways, if there are any existing data that somebody would have collected prior to our update, and those could be used as an open source public data set, we would like to incorporate them so we do not do work as a double capture. That would be a great way of automation. But other than that, it has been proven that, let's say, some classifications from remote sensing data are helpful, but to the level of accuracy that we are trying to achieve, on-screen heads-up digitization to be proven to be the most efficient way of doing that. We have streamlined the workflow, process of data capture for entire province, so we are able to do on-screen capture more efficiently, and we actually, that streamlining and optimization allow us to move to that annual updates cycle.
So next question was, are there any plans to let people sign up for email alerts when new data are released? I think that if you were to sign up for the ABMI e-newsletter, that could be something that would be very easy for us to include in there, and probably very valuable for folks. So I'd encourage you to visit our website to sign up for our e-newsletter. Okay, so another question from Dan. When a harvested area does not have a year attribute, when do you figure it was found on the landscape? So in other words, an attribute year of 0?
We did our human footprint inventory. Each polygon has year of origin attributed as non-null value, so there should not be a zeros. When do we have a polygon that we are capturing for, let's say, 2017 update? We do have access through data sharing agreement to spot imagery from Government of Alberta, and we digitize the new catalogs, and automatically for those year of the origin is going to be assigned as of 2017. If we do have polygons that for whatever reason would not have information on a year value, we would go to our imagery catalog, again shared with data share agreement from Government of Alberta, going back through various spot imagery mosaics down to or back to 2005 and 1999 year. Other than that, we are also using Google Timelapse. So Google released their data going back to 1984 as a seamless mosaic of imagery, starting in 1984. That's based on Lancet imagery. And to go to the deepest in the timeline, we do have access to orthophoto mosaic that has been created based on aerial imagery flown in 1949, 1951 year. So that's as deep as we can get to get year of the origin for the catalog.
Okay. That looks like all of the questions. If anyone else has any other questions, please submit them now, or we will wrap up the webinar, and make sure to post this so that it's available for anyone who is unable to attend. Oh, John has pointed out there was a typo in my email address. So it's bacampbe@ualberta.ca. Okay, that looks like it. I don't see any other hands raised or questions posed. So I just want to take a moment to thank you all for joining us today on our first webinar. We are looking into hosting webinars for several other of our products in the future. So stay tuned, and we hope to have you join us again. So thanks a lot and have a great week.
Thank you.